Hello everybody and welcome back to another one of Jason's videos. And today I have brought you a new MCA preparation problem. This time the problem is not anything about logical reasoning, and it's all about utilizing the division properties of different numbers. The problem asks for the remainder of a number that consists of 2017 sevens when it's divided by 30. So your first thought might be that we can just solve this problem by finding the patterns of different amount of sevens divided by 30. And yes, that is one way we could do it, but that's not necessarily the best way. The best way to do it is by utilizing the division properties of the different numbers, and then we can find out what the answer is. But since by just finding the pattern, it'll be easier for you to understand, we'll start with that method. So in that method, we find the different patterns of different amount of sevens when it's divided by 30. So we start with 1 7. 7 divided by 30 equals to 0. Remainder 7. And the remainder is really important, and you'll know why later. 77 divided by 30 equals to 2. Remainder 17. And then 777 divided by 30 equals to 25, remainder 27. 7,777 divided by 30 equals to 259, remainder 7. 77,777 divided by 30 equals to 259 and another 2, remainder 17. So now you might see there's a pattern going. Here there's from 17 to 27, and then here it's probably going to end on another 27. And yes, when you keep on doing the math, it'll keep on going like 7, 17, and then 27. Like this, we can just make sure that it's 7, 17, and 27. And then it keeps going on. Oops, it's a 27, 27. And then it keeps on going and going. So, but that doesn't really matter since we haven't found to answer it yet. So now, since we know 3 numbers is a loop, we can divide 2017 by 3, and we'll get the answer of something. But then the quotient isn't really important to us because we only need to know the remainder to find out what the remainder is of it divided by 30. So then, using the division properties of 3, we know that the numbers digits must add up to be a multiple of 3 to make the number a multiple of 3. And right now, if you add up the 2017's digits, 2 plus 1 equals 3, and then 3 plus 7 equals 10. That doesn't make it a 3's multiple. But if we just change that 7 to a 6, we can make it as 2016's digits add up to 9. And 9 is a multiple of 3, so 2016 would work. But then the question asks for 2017, and we really only need the remainder, so we'll just write the quotient as m. M, remainder 1, since 2016 works, and 2017 minus 2016 equals to 1. Now, if we label the pattern from 1, 2 to 3, 1 again, and this is the 2. So then, since we're looking for 1, and 1's remainder is a 7. So then, that means the answer to this question would be 7. And so this is the first way to do it, not necessarily the best way. So now, the second way, as I said, is by utilizing the division properties of different numbers. And that in this case is 3 and 10. because 3 times 10 equals to 30. So if we find a number that is divisible by 3 and 10, we can know that the number is divisible by 30. So now, you probably know the divisible pattern for 10 and 3. So the divisible pattern for 3 is that when all digits add up to a multiple of 3. And the division property of 10 is if it ends on a 0. So now we know that the division properties are these. We can try and use them to solve the problem. So in this number, we know that there's 2017 sevens. So then we have to find if it's divisible by 3 first. So then to find out if it's divisible by 3 first, we need to know the total of its digits. And to find that, since every single digit in this whole number is 7, and there's 2017 of these, we can just do 2017 times 7, and that'll be 14,119. So now that's our answer. With this answer, we can find if it's divisible by 3 or not. So this thing would be 1 plus 4 plus 1 plus 1 plus 9. And that would make a total of 16. And 16 is not divisible by 3. But if we just change this 9 to an 8, and we do 1 plus 4 plus 1 plus 1 plus 8, it'll make 15. And 15 is divisible by 3. So now we know that 14,011 and 8 would be a multiple of 3. We should use it on this huge number. So then in this number, since it can only be divisible if we have one less number, that would make it end on a 6. So instead of being 2017 sevens, we can change it to 2016 sevens, and then the last number is a 6. So that will make it divisible by 3. But how do we make it divisible by 10? So if we want to make it divisible by 10, apparently this method won't work if we do it like this. But then to make it divisible by 10, we just need to change the last number from a 6 to a 0. And by changing that, we still need to make sure it's divisible by 3. So a 6 minus a 0 is 6 in difference. And 6 divided by 3 is divisible by 3. So if we change the ending 6 to a 0, it would still be divisible by 3. So if we change it to 2016 sevens and 1 0 at the end, it would still be divisible by 3. And I can also prove it to you. So like this, like if we get rid of that 7 and turn it into a 0, we would have 7 less number, and that would be a 9 minus 7 equals 2. So we put 2 here. 1 plus 4 plus 1 plus 1 plus 2 is equal to 9. And 9 is divisible by 3. So here this is. And now we need to find the answer. And to find the answer, we simply have to subtract the original number of a bunch of 7s by this number, a bunch of 7s, but then the ending number is 0, and that would make a difference of 7. So we still get to answer 7, but you noticed it took up less space. So the second way I think is relatively better than the first way if you know how to do it. Thank you for watching.